Based on public verifiability and the cloud's data dynamics and storage security using multiple TBAs. Actually, this is the work that I'm trying to adopt in my PhD studies. Now, with my work with my guide, we are trying to improvise and make some other changes for this team. This team actually is the problem that we are all facing nowadays in the world of IT engineering. The basic thing is we are dealing with the authentication, we are dealing with the security of the information, which the goal that we are seeking here is how we can ensure the integrity of the message and not to be hacked, not to be frauded, not to be any sort of change that is not going through the process that we are trying to demonstrate here. So, the starting of the thing, as I can show you here, is the work of us is dealing with the authentication. What we are trying to do is to adopt a new method. The new method is telling us that we are trying to do one conceptual work, which is something called the TBA. Before, the TBA has been demonstrated, has been presented as a third-party auditor. Because the cloud computing, which is the thing that I'm trying to demonstrate in here, cloud computing is basically services that are there, are based on infrastructures, are based on platforms, are based on softwares that we are trying to develop, or we are trying always to enhance, and we are getting the user to give them, whether he's using the pay-per model or whatever sort of method that he is going to. So, before, for the sake of the security and for the sake of the information not to be manipulated, not to be stolen or getting any sort of fraud thing, we are using the TBA as a third-party auditor. So we can prevent the client himself from changing the data that has been stored already by him. I mean, this guy will try to go to the cloud. I have a project. I have, for example, a company thing. This company, I'm having products. I need these products to be developed, for example. So I go through the cloud computing. The company, I mean, he goes to a site, a company that is trying actually to give you a space for storage thing in order for you to establish your work. For example, establishing a site for your own business or just to do the advertisement thing. So the third party will be a person between us, I mean the clients, and the people whom they are working in the cloud computing. This guy will be controlling the whole process. It means this guy will, the client will upload all the info that he needs to, for example, save or needs to put whatever it is, the process that he's adopting, and general control of it. The third party here is the person who will actually try to do the authentication, who will check whether this is right or not, whether this is will be suitable for us or not. So, along with this thing, we are going through some other processes. It is called the checklist. Before, in the IT field, I mean, talking exactly about the cloud computing. The problem it was, as I said from the very start, is we cannot make sure that all the info that we are receiving are actually 100% right and not manipulated. So when we invented the third-party auditor, actually the work before me, it was talking about the third-party auditor. So I'm not the person that has invented this like 100%, but I developed something. So I will show you right now how this thing will be happening. Along with the TPA, we are going through something called the checklist generation. Checklist generation is working in another way in order to do a status for how many times we saved, how many times we got ratios for the manipulation, so we can disclude, we can actually discard some of the features that we think, for one reason or another, they are just suspicious. So here I'm showing the rate of changes that are related to the cloud computing. So many things, but the most important thing which we are focusing on is the security and the performance and the availability, which I will come to tell you right now what is this thing. The problem statement, actually I guess I can skip this thing because I just explained to you in advance what is this thing. But basically is what I said, that we are focusing on the security, focusing on the performance, focusing on the availability, because these are the three major concepts that nowadays they are a huge challenge when it comes to cloud computing. Moving to a small introduction I made to know what is cloud computing. So basically it's saying that the cloud computing is what we said, it's an infrastructure. Now I'll come to explain, but generally it's any sort of service that you can get through the internet, which is available to you through the internet. How this will be possible, we will try to explain later on. So, these are the three different types of the cloud computing. Is the infrastructure services, is the platform services, and the software services. Starting with the infrastructure services, the infrastructure services are basically making a virtual server. This will be like a huge company will provide us with lots of servers. These servers are providing a storage space. So for you to upload all your, for example, you are having an application, you developed your own application, you want people to use this thing. So usually to log it through the internet, you have to put it there at the first step. So how you can put this thing there? You put this thing there through making an allocation for you. How this allocation is happening? It's all through the virtual server. So the virtual server will be there. We usually pay sometimes just like rent, if I can say so. We can understand this from our daily life thing, how we can understand the cloud computing thing, how it is working actually. So when I rented that area, I put everything in there. All my services now are powered by some other applications, which they are the virtual servers. So you can see here, provide a virtual server. The server is used to store, access, configure, and store their virtual servers as well as storage. Now, this is the concept now. If you see, for example, Google. It's one of the biggest examples of what we are having here as an infrastructure, because this company is a standalone company. It's having its own infrastructure that we are lurking sometimes. We are just going, asking, for example, or trying to find a way in order to allocate our services to be powered through them. Now, if we will go just a little bit, watching what is the meaning of a platform service, which is the second type. So in the cloud, saying that platform services is just a product development and a software tools. So what is the meaning of that? It means sometimes when you go, for example, go Google Apps. Now it is also powered from Google things. So still, the infrastructure has given us another concept. These apps, which we can use, we go there, sometimes you need to design for something aside or whatever it is. So instead of you having the feature to do this thing, Google, for example, which we mentioned earlier, they will provide you this infrastructure thing, but in a something called the platform thing. Now, what is the meaning of that? They will provide for you the tools for you to use, for you to do whatever you need. Still, at the end, you are saving costs because you don't need to buy these things. You're saving money, while you're being, of course, and you will do the most important thing, it is saving time, which is the most, actually, the ultimate goal as our perspectives as engineers. That's how you should think about these things. Going to a software services, this model is the infrastructure thing, is a software product and a hardware product that are provided by a vendor. Their interaction with the user is happening all through a front-end portal. Now, how is this thing is happening? This is easy. You can even look at these things, for example, when you are going through ATM machines. Now, what are these things? Are all connected. All the databases are made through infrastructures, are made then to a minimum thing, which is the platform, and the end of it, which is there's nothing at the bottom of this, is the software. Because they will give you this thing, which is connected all the way to what I mentioned. You will have to just stand in front of it with some sort of an interface thing that will make you capable of interacting in one way or another, but the whole process is connected actually in so many steps that we don't even have to know about these things, especially only the people who they are in the field. So this is the cloud computing conceptual diagram. As I mentioned to you, the cloud is basically, and it has been mentioned as a cloud because it is not having a specific infrastructure. So the shape of it, as a cloud, we have the Salesforce, we have the Microsoft, we have the Amazon, Rackspace, Yahoo, Google, whatever it is. So we see, one of the concepts is saying that we have the pay per model. So what does it mean of pay per model? Actually, when they first invented the cloud computing, it's so easy. As now, I'll give you an example. You are sitting at home, you are having all the services. For example, you have a plug switch. So you need sometimes to plug it, for example, to charge your cell phone, or you want to start your TV, or whatever these things are. So what you're going to do, you're going to put this switch, you're going to get the electricity, the power, the current will go, and actually the thing will be working and functioning. At the end of the month, what will happen? Of course, you will receive a bill. This bill is saying that how much electricity that you have spent, or how much, for example, the lighting or whatever, in general, the water, whatever it is. The same concept is going in here. We are having all these things to be delivered to us, but we ain't actually trying to have them. So this will be having the capital thing will be in one place only, and we are only the people who they're trying to interact to get only what is requested from us to do or what we need actually to do. Benefits of cloud computing is so easy, and I just mentioned to you the things. The most important thing, as I said, is the reduced cost, because we don't have to own the thing. We have just maximally to rent it, to pay for the services as much as needed. The more it is not needed, the more it is not required, the more I should not pay. So I will save money by this. Increase the storage, of course, because the infrastructure is providing huge servers. The huge servers are giving us a huge possibilities and a vast, actually, I can say, memory space. So for us to save. And the flexibility, everybody knows that the performance, the availability, the security is there, and the more they are cooperating with the user, the more the interfaces are easy, the more I can understand, the more that I will interact, and the more the benefits will be. So once I will get all these things, it means that this software, this application is in one way or another flexible. Cloud computing, and this is quite catchy, because this is mentioned like cloud computing, everything at the kitchen sink. Now what do we mean by this? Why we are mentioning the kitchen sink? It says here, cloud computing we are having app server, we are having database, this is what I mean. If you see, the app server actually, it means that we are talking about the infrastructure service. The database, it's just a base of it, because everybody has to have a database in order to develop this system here. So the code, it means that, for example, any device that is trying to interact in one way or another, a mobile or a PC, kitchen, why the kitchen? Nowadays, you see sometimes you can even control your house remotely 100% just from your own cell phone. This always happening through you connected to the cloud, through some sort of applications, whatever it is, in order to give you the whole picture and the whole image. So even this small idea, maybe this thing people will look and they say, you know, this is strange. But this is strange because this is a new, because this is what is going on nowadays. So the proposal for my thing, which I tried to implement, how we can get this as possible as beneficial for us. So the proposal book, before my job, when I looked at the problem, I found, and one of the last papers were there in IEEE, I guess you know about this, it was mentioning that we are having only one client, we are having only one CCS, which we call it, it's related to the cloud and its own storage. So before there was only one TBA. The person that is the third party that is trying actually to check all the info, make sure that our data is like making sure of the integrity of the data and the storage of it, in order not to have any sort of manipulations, as I said. So the problems with this thing, it was before. First of all, what is happening? What if this TBA actually, for one reason or another, stopped working? Now everybody knows that everything is happening now through the world of the internet. It's just so fast. We cannot afford even to lose some time. So if this TBA actually stopped working, it means I will have more jam of the traffic, because maybe the lots of traffic will cause lots of load to be on this TBA thing. So if this will stop working, we will have actually a problem. That's what we said. We propose a general formal model. What is the meaning of formal? It's the proof of retrievability. It means one of the models before to check the data. How is this possible? So it's same with public verifiability of cloud data storage, in which block layers verification is this. So this actually, it was a problem before, because that's what we are trying to solve in here. The second part, we are equipping this proposal, pre-OR model, which I said, proof of retrievability thing, with a new construction, which is our new world. Now how are we going to do this? We will equip this thing in order to enhance it with a couple of TPAs. So my theory is saying, instead of me sticking myself to one TPA, I will develop 2 or 3 or 4 TPAs. It means N of TPAs as required from me, what the project actually is requiring. So as you can see, even I highlighted this thing in here, for supporting for fully dynamic data storage operations, especially supporting block insertion. Block insertion, it was already missing from all the previous models. That's why what we are having, we're having before a problem that whatever comes in, I cannot even check whether it is 100% harmful, useful, right or wrong, secure or not. That's why it's called the block insertion, which it was not there. When the block insertion has come, it is putting and setting limits for us. So the TPA will be having some sort of standards that is going through them in order to tell us that, all right, you know what, this info, I've checked them, actually, they are authenticated, this thing I can accept, it will be uploaded and it will be in the database for anyone to use because it has been guaranteed like 100% or almost whatever is there, that it is right actually. So the thing is, see, the multiple TPAs working in this mode was between the client and the CCS. We propose the security of the proposed construction, and we are actually justifying the performance of it, how we can use this through the comparison of the state of the art. The last thing is there, which is the most important thing, is we say, we have in it, the IT auditing, we have in the checklist generation. So this will enhance the job of it by making it just like that. This is the figure which I came up with in order to enhance and present to you easily the work of mine. The following figure is showing the architecture of our proposed multiple TPA system model. Now, before it was just like that. Simply, I have a client environment. This is just in general, whatever is supposed to be. The client's environment was already trying to connect all the way to the, actually the CSS. Here I'm talking about the cloud in general. Before, the connection was having only one TPA that is holding the whole information. I explained why we don't do this. That's why the new work for me will be, I hope, as in the future thing, is to apply more than one TPA, of course, as required, and of TPAs. So we can see that in between is what I mentioned, the security of the message flow, because that's what we are trying to actually implement in here to get all these things secured as much as possible. Types of clouds, which I can explain to you fast, to you actually, public cloud and private cloud. Some people are saying community cloud, but I've tried not to mention the community cloud because it falls in the same category of the private cloud. So we're going to a public cloud. Public cloud is basically that, as I said from the very start, any person can log into the internet and get them services, whether buying them, whether hiring them, whether getting any sort of means for this thing. But the most important thing, you will get them as much as you can be looking into it because these are available almost for everybody. So see these platforms which we are having here. And the infrastructure, what we say, the virtual servers, other services. Users can share them resources, whatever it is, in order to get all these things that it is required for them to be giving. Actually, this thing will teach us one thing, which is I mentioned from the very start. You are focusing on the time, you are focusing on the costs. So I mentioned in here that it is giving us market and cost savings. The most important thing is the private cloud. Why? There's no difference except for one thing. This will supply for a limited group of people. In order for us to enhance our job, to find a place that we are hiring for our company, so some provider having an infrastructure will be the person who will actually give me all the, how can I say, the supplies that I'm requiring actually. So basically, it's having the capabilities like the automation, the self-service, and the chargeback. And the objectives, we say that the objectives we are having is to motivate the public auditing system, which is one of the major problems that we are having now, and that storage security in the cloud computing. And we suppose that propose a protocol supporting the fully dynamics of the operations that we're having regarding the for example, the storage or whatever these things that we are mentioning in here. So the block insertion, which is missing from the existing scheme. To extend the scheme to support scalable and efficient public auditing, which is the most important thing in here, because cloud computing is using the IT auditing and the checklist. Before I said it is not mentioned, it is mentioned just briefly. If you want to do something there, regardless in the future, then you have to enhance these auditing things with multiple auditing tests, because the thing is, this will give us one of the major concepts that it was not prevented, not to be like published before. It was prevented before because it was not even meeting the needs. But actually, if you apply this based on the calculations we did, there will be a concept called the batching. What is the batching? It's basically the multitasking thing. So I will be requesting, or I will be handling more loads as much as requested from multiple users to be handled once. So this enhancing us, it will be causing like more processing, more whatever these infrastructures, causing the hardware and whatever these things. The more they are enhanced, the more they will give us actually the whole process to be even faster and faster and to group more requests. And to prove the security of the proposed construction and to justify the performance Because actually this will all happen to us through concrete implementation and comparisons with the state of the art. And thank you very much for your time.